If I don't specify on a quiz or test, then put it in whatever form will convey your answer. Textbooks tend to say, what is the magnitude and direction? And they're in essence asking for polar form.
So, where are the arrows in that function? Because it's 6 to the right, do you put a right arrow before the 6? Or just leave it?
I don't need to put a direction here because I defined it over here.
The I hat is acting as a replacement for saying go
Oh.
to the right. And J hat is replacement for going
Is that
saying going
second
up.
thing with the hat a J?
Yes,
Oh, okay.
my I's and J's curl in different directions. I, J.
Okay.
So these three things would represent the same vector, so my vector here, I just call it A. And the form that you would use would be the one that's most convenient. Okay, questions? All right, let's apply this incredible knowledge here. Let's say I have a vector that is 30 newtons, 20 degrees. And I want to figure out what is this vector in rectangular form. Now, I could put it technically in any direction. Well, I'll show the shortcut and the abuse of the system in just a moment. Let's do it the standard brainwashed way, the math people, horizontal, vertical. So I'm going to basically break it up into components, into perpendicular components. And so I'm going to define first my coordinate system here. I hat, J hat. I hat is not always to the right. It just happens, that's the way I'm drawing it right now. So if I'm defining this as to the right and up, then I'm breaking this up into horizontal and vertical. So I need to figure out how far to the right, how far up, and that is a right triangle. I create a right triangle. I'm going to label this little a, little b, and I bring in my trig functions. I know that the cosine of 20 degrees is going to be the ratio of the adjacent side over the hypotenuse. Doing the fancy math here, just turn it into two fractions equal to each other, cross multiply. A is equal to 30 newtons cosine 20 degrees, which is 24.7. I don't know, no one's going to tell me. Thank you, Stephanie.
I can't see the board.
Yes, Claire?
From my specific angle, your head was blocking.
So you're saying I got a big head?
Yes.
Okay. Fair enough.
Cosine 20 degrees, 0.93.
Let's do, wait. Cosine, so cosine is times 30?
Degrees?
Degrees.
What? Why are we finding degrees?
Or not?
Okay, it's newtons.
Yeah. I got my unit right there. Cosine of 20 degrees is just a ratio of sides. It doesn't have units. Unless you really want to do something funky, but I recommend against it. So then my horizontal component is 28.19 newtons. My vertical component, well, I know my hypotenuse, I know my opposite, I'm going to be using sine, and so B is going to be my hypotenuse times the sine of 20 degrees. If you need to go through the intermediate steps. Sine of 20 degrees is the opposite length divided by the hypotenuse. Solve for B. And we end up with 10.1. I guess you're just trusting me on that?
10.26.
Ooh, that was close. 10.26. So my vector, 30 newtons, 20 degrees, is the same thing as 28.19 newtons I hat plus 10.26 newtons J hat. They're equal to each other, it's just two forms of the same vector.
Is that a 26 or a 20? I can't tell.
That,
No. The one after 30 n.
that's 20 degrees.
Okay, thank you.
Let's see, razor. Questions to hear?
Can I take a picture before?
Sure. Do you want the class to get around it and pose? You do a Carol. Sorry, there's my big head out of the way.
Thank you.
Okay. The addition of vectors, let's add some vectors.
Do the units change if we do?
Does units change if you add?
Sorry, the I hat and J hat, do those go away if we do? Or do they just combine, like IJ hat or something?
The I hats combined, the J hats combined.
So they don't combine together?
I hats and J hats, no, they're perpendicular to each other,
So how are we gonna add an I hat and a J hat with no other I hats or J hats?
we added an I hat and a J hat right there. You want a single, nice
I
little
think
answer?
I have a migraine.
Okay. Physics cures migraines, doesn't it?
No, I have chronic migraines.
Maybe it's because you've never had physics before.
Uh-huh, sure.
Yeah. As you might tell, I took biology in 1979. All right, so if I have a vector, let's stick with the 10 meters and 20 degrees. And I want to add to it, I guess I did newtons over there. So let's make that 30 meters, we're changing units. And I want to add to it I'll make it 40 degrees and 20 meters. So I want to add these two vectors together. You can go through, do law of sines, law of cosines, some non-right triangle trig, have at it. It's not the method I'm going to go through right now. What we're going to do is we're going to first put them into rectangular form, and then add them in rectangular form, because it's so much easier to add them if they're in rectangular form.
And again, rectangular form is like 30n plus, 30n comma 20 degrees, something like that.
One more time.
That's ball.
What, again, does rectangular form look like? Is it that, or is it the same as polar, with different units?
This is polar form, this is rectangular form.
Okay.
Plus 20 meters. What's the angle? There's a difference, if you put 40 degrees here, That's not this. Where's 0 degrees? Which way? I assume -40 is what was being proposed?
Are you going like the unit circle or just from baseline?
All right, so with I hat, J hat, we are not automatically going, I hat's always this way, J hat's always that way. With I hat, J hat, we define it. Just, they need to be perpendicular to each other, that's the only restriction. If you get into more advanced physics, you can start getting into situations where I hat and J hat are not perpendicular to each other, but that is well beyond the scope of this course. But we are sticking with the convention that 0 degrees is that way, from your point of view. These are positive angles, these are negative angles. So -40 degrees would be the appropriate to indicate it is a 4th quadrant angle. If I'm going to put it in rectangular form, I need to define my I hat and J hat. I hat, I'd say let's keep it on the horizontal for right now. Left or right? Which one do you want to make positive I hat?
Left.
I saw some thumbs earlier indicating this way to make I hat. Which way do you want to make J hat? Up or down? I saw up first.
Okay.
We'll change one of them in just a moment, just so you see what it looks like. All right, so this one right here, we break into the horizontal and vertical components. We pretty much just did that. The only thing that's different are units. So this is 28.19 meters I hat plus 10.26 meters J hat. That is the first vector, plus. Now we have to break this up. Well, there's two major ways of doing this. There's the, I guess, the brainless way, and then there's the thinking way. Let's do the thinking way first, and then we'll do the brainless way. So I'm gonna draw the triangle. So I've got this way and that way. My opposite side here is going to be the hypotenuse times the sine of 40 degrees. And the adjacent side here is the hypotenuse times the cosine of 40 degrees. And now it's calculator exercise, which someone will now share with us. You want to do it, Stephanie?
Yeah. Cosine is 15.32 degrees. No. Wait. No. It is degrees. Yes.
What did we settle in on?
Degrees. Meters. Too early for physics.
Oh, we're not finding, if you're finding an angle, then it's a question of radians or degrees. If you're not finding an angle, then you're not gonna have radians or degrees. And this one?
12.8558 meters.
There we go, all right. So I need to express this in rectangular form. I know that to the right is I hat, so I'll just write down my 15.32 meter I hat plus 12.86 meters. J hat is what you said? What's wrong with that?
J hat, that's not the right direction.
Yeah, J hat is up, and this one's going down. So-
K hat?
No, K hat is if we're going in or out of the border. How do we indicate the opposite? Yeah. It's, if J hat is this way, down is negative J hat. Now, you could write it as 12.86 meters negative j hat. That is awkward, and I do not recommend it.
Why not just minus 12.86?
And that is exactly the way it's done. The minus sign comes out front, negative 12.86 meters j hat. The big argument against this is I've had too many students do it this way and not write the parentheses. And if you don't put the parentheses in there, this suddenly becomes a scalar minus a vector, which is not something math has figured out how to do yet. So, negative 12.86. And now we can add them easily. You add like terms. I have the I hats here. Oh, let's see, so it's 0.51 and then 43.51 meters I hat minus what's 2.6 meters J hat. This is, given the problem was to add these two vectors, we have an addition right here, this is rectangular form, we're done. Some students are not satisfied by that, and they just want to keep going because they want to put it in polar form for whatever reason. Sure, nothing wrong with that. You open yourselves up to potentially more mistakes. But let's do it anyway. Put this back in polar form. I'm going to start, I have a coordinate system here. I'm going to start here, I'm going to the right, 43.51 meters, and then I go down 2.60 meters. When you're adding vectors, this is known as the head to tail method. You draw one, you're now at a new spot, that's the new starting point, and then you draw the other one. Your resultant, which is just the fancy name for sum of vectors, the resultant is from where you started to where you ended. That green arrow is the answer. But we're not in polar form yet. We need to figure out the magnitude and the angle. How do you find the magnitude?
A squared plus B squared.
Yeah, you started, then you,
Oh, equals C squared.
okay. I didn't know if you just assumed everyone knew or you like. Sorry, flashing back. Anyway, so if we label that, say C, if that is my resultant, this is the one time I use the double print to represent a vector. Then R, the magnitude, is equal to 43.51 squared plus 2.60 squared. Now notice that as I set up this problem, I didn't write the units. I only need to make sure the units are there in the end. I don't have to write the units throughout the entire problem, just so long as I know what they're supposed to be in the end. So we have the magnitude is equal to, did you get to the square root at the end? Maybe. All right, so in polar form, for those fans of the polar form, how would I write my answer? Or at least the first part of my answer.
Number n,
Say number m.
n, number of newtons.
We're not dealing with newtons here.
I would put 43.59 meters.
Yep.
Is polar notation the same thing as regular notation, but with different, like, units? Like, I thought polar notation was just n.
No, polar notation is whatever the magnitude is with the appropriate units, followed by the direction. So now we have to figure out the direction. should be something close to 0, or close to 360 degrees. So we need to find this angle right here. Once again, our friend trigonometry helps us. I'm trying to find this angle right here. I have a value for the hypotenuse. I have the two sides. Typically, it's recommended that you use the numbers that have less rounding in them. 43.51 is rounded, 2.60 is rounded, but the hypotenuse is rounded based upon those rounded numbers. So tangent is generally the recommendation. Quiz or test, I'm not going to take off for it if you use one of the other ones. So I know that the tangent of theta is the opposite over the adjacent, so that's 2.60 meters divided by 43.51 meters. Meters cancel out, which is fortunate because it should be unitless. And so theta is the arctangent of 2.6 over 43.51. Which is 0.06 radians. What is it, degrees? 3.42. So how would I write my final angle?
Negative 3.42 degrees.
Yes.
Is turning it back into polar form gonna be on quizzes and tests?
I'm trying to think of any quiz or test that I've written. The quizzes tend to be based on textbook problems, so they might be in there, because textbook will do it.
Okay.
But on any test, I don't think I've ever specified form. Right, yes, Eva?